So today we're going to cover section 2, still same P2, but today we're going to continue, and today we'll talk about negative exponents and rational exponents. Whenever I use the word rational, I'm talking fractions. So here is the first slide, and it says negative exponents and dividing with exponents. So we're going to be doing two things here. So exponential expressions with negative exponents move from the numerator to the denominator or vice versa. Some people think when they see a negative exponent, they think reciprocal. Do not think that a negative exponent makes the number negative. It does not make it negative. And then yesterday when we multiplied exponents with the same base, we added them. Now when we divide, we're going to subtract. So just to clarify from yesterday, remember if you were doing something like 2 to the 3rd power times 2 to the 4th power, you do not multiply the 2's. All you do is add the exponents, and this becomes 2 to the 7th. Same idea here when we divide. When we divide, I'm going to come back to the negative in a minute, but when we divide, if we have the same base, and we're dividing, we don't divide the 2's, we just subtract the exponents now. And we would get 2 squared, and then we could figure out that that's a 4. Now, if it's backwards, let's say it was 2 to the 5th on the top and 2 to the 7th on the bottom, this is where our negative exponents are going to come into play. So here I would be doing 2 to the 5 minus 7, and then this would give me 2 to the negative 2 power. Okay, this doesn't make the number negative. Notice in the instructions here it says expressions with negative exponents move from the numerator to the denominator. So what I would do is take this and move it to the denominator, this whole thing, and then make the exponent positive. So when you have a negative exponent, it makes it a fraction. So now let me clarify this. So up here, exponential expressions with negative exponents move from the numerator to the denominator or vice versa. So let's say it's a whole number with a negative exponent. If you want to make it a fraction, notice that 5 to the negative 2 is in the numerator. To make it positive, you move it to the bottom. And then you would evaluate and get 1 over 25. If it's in the bottom of a fraction, let's say it was set like this, to make it positive, you would move it to the top. You can also think reciprocal here. And then this one would equal 25. Because you switch it to this, and then you do the problem. Let's try some examples. So now, as soon as you see a negative exponent, remember it doesn't make it negative, it makes it a fraction. So I would take the 4 to the negative 2 power, put it underneath a 1, make the exponent positive. So again, if you want to think of it like this, that you could turn that whole number with that exponent into a fraction by putting a 1, then you flip it. This goes to the denominator, the negative sign goes away, and then you do 4 times 4 and get 1 over 16. The next one, same thing. You could put a 1 underneath here, flip it, and 1 over x cubed. Now this next one, you need to be careful. This negative 4 is only on the x. There's no parentheses around it. So the 2 is going to stay where it is, but the x to the negative 4 moves to the bottom. It's the only thing with the negative exponent. The 2 stays on the top. Now, if it were something like this, 2x to the negative 4, then you would have moved the whole thing. But as it's written, this problem, the only thing that has that exponent is the x. Now, when you have a fraction that's raised to a negative power, here's where it really helps to think reciprocal. So what I do whenever I have a fraction, I flip it, change the exponent to positive, and now do the problem. Remember, this power of 3 goes to the numerator and to the denominator. So this would actually turn into 5 to the 3rd power, which is 125, and 2 to the 3rd power, which is 8. For number 5, again, if you want to think of it like this, you're going to flip it. Notice the negative 4 is in parentheses, so I'm bringing it all the way down. Make your exponent positive. And here's with the parentheses, and the exponent is even, so this becomes a positive 16 in the bottom. Now notice these two look the same, but this one doesn't have parentheses. So now the only thing that's raised to this negative 2 is the 4. So if you want to think of this as negative 1, like that, so the negative 1 would stay in the top, this negative sign, and then the 4 to the negative 2 goes to the bottom. Now, one thing I want to clarify is whenever you have a negative in the top, or a negative in the bottom, or a negative in front of the fraction, all 3 of these mean the same thing. Okay? If, however, you had 2 negative signs, a negative divided by a negative would turn positive. But a negative sign, just one negative sign, either in the top, bottom, or in front, it just makes the fraction negative. Pretty good? Okay, let's try some more examples. Again, this negative 3 is only on the y. It's the only thing that's going to move to the bottom of the fraction. The x will stay on the top, but the y will move to the bottom, and then the exponent becomes positive. Number 8. I need to simplify the fraction, so I need to simplify the 4 over 16. I can reduce this to 1/4. And then for the exponents, I'm going to subtract them because I'm dividing here. So I would do x to the 3 minus 4 power. I get x to the negative 1. Whenever you divide, and if you end up with a negative answer after you subtract, then that ends up, you write that variable in the denominator. So my final answer here would be 1/4, and then you would write this x in the denominator. If this were a positive 1, you would have written it at the top. You're pretty good? All right, let's try number 9. I'm going to look for all of my variables that have a negative exponent, because those are the only ones that I'm going to move. Everything else that isn't have a negative exponent stays where it is. So the 4 and the y squared stay in the top, and then I would move the x to the negative 3 to the bottom and make it positive, and the z to the negative 4 also to the bottom. Now, for number 10, we've got two different methods we could go about to solve this one. I can either decide to subtract the x's because I'm dividing them and subtract the y's, or I could move the exponents, make them positive, and then work with it. Either way. So let me go ahead and move the negatives like I've been doing. I'll show you both methods. You can decide which one's going to work better for you. So I could take the x to the negative 2. It would move to the bottom. And the same thing for the y to the negative 3. It would go up. So if I do it this way, the 3 will stay. The y to the 4th is staying, and so is the x to the 4th. So then what I could do is move the x to the negative 2 to the bottom and move the y to the negative 3 to the top. Now remember, this is like last night's homework. When you multiply, you add the exponents. So this would become 3, and then add those, and then add these, and that's one method to do it. The other way is you could use your division rules. So let me rewrite the problem. I can take the x's and subtract them, and the y's and subtract them. Now the 3, there is nothing to simplify with it, so it's going to stay in the numerator. Now for my x's, if I do negative 2 minus 4, you see how you get x to the negative 6? So that tells me put the x in the bottom. So that would be the blue. Then if I do the red, I'm doing y to the 4 minus negative 3. Keep flip change, it becomes y to the 7th. The 7 is positive, so it goes in the top. You can do these either way. Good? Let's try some more. I'm just going to keep practicing this. Here's a pretty simple one. It's division. So we're going to do 5 to the 9 minus 7. Remember, we don't divide the 5s. You keep the base, just subtract the powers, and you get 25. Next one. This one again, same base, so I'm going to subtract 14 minus 10, x to the 4th. Now, this one looks the same, but it's flipped. So I'm doing 10 minus 14. I get a negative 4. Remember, when you have a negative exponent, you put it in the bottom of a fraction. The bases are the same. We're doing 5 minus negative 3. Keep flip change, or stay change change, and it becomes 7 to the 8th power. All right, now on this one, you can do it either way. You can either decide, I want to move this to the top and this to the bottom to make them positive and then simplify, or you can do 15 divided by 5 and get 3, and then do x to the -4 minus -8 power and get 3x to the 4th and be done that way. Or you could flip-flop it like I said, put the x to the 8th on the top, x to the 4th on the bottom, and then you still have to subtract. So you would divide the 15 and the 5, get the 3, and then do x to the 8 minus 4 and get 3x to the 4th. So it's almost easier to just take the two variables that have the same letter and subtract their exponents. Same thing on this one. Like I can reduce the 15 over 25, make this 3/5. And then for the a's, I'm going to do a to the -5 minus -2, which really becomes -5 plus 2. So this becomes a to the -3. It's negative, so I write it in the bottom. And it's positive though. And then I'll do the same thing for the b's. I'm going to subtract b to the -1 minus 4, b to the -5th. So again, it's negative, so I write it in the bottom. So you can do it either way. If you want to flip them, you can. I think it's a lot easier just to subtract them. You find the ones that are like. Two more examples, and then we'll get into the fraction exponents.
Wait,
Yes.
Corey.
Yes.
The a at the bottom in the original equation, it's a negative. It's to the -2nd power. So shouldn't it go to the top?
Okay, so you're doing it that way, you're flipping them? Okay. I just subtracted the powers, so I just took the a's, the -2, I just took -5 minus -2, and then that's how I got -3. But let's go ahead and do the way that you want to do, and let's switch the places. So you can do it that way too. So 15, a to the -5, b to the -1. I'm just rewriting the problem. So I'm going to reduce the 15 over 25. I'm going to move this to the top, this to the bottom. So a squared is in the top now, a to the 5th in the bottom. And then I'm going to move the b's all to the bottom because this is already down here. And then I'm going to move this one down. With me on that so far? So then now we have 3/5. I'm going to subtract the a's. 2 minus 5. I get a to the -3, which tells me write it in the bottom. But the b's are already down here. So I just add 4 plus 1 and leave them down there. And I can get the same answer either way.
Okay, thank you.
Mm-hmm. All right, two more. Let's do 17 and 18. All right, so again, we have a fraction that's raised to a negative exponent. Soon as I see a fraction raised to a negative power, I'm flipping it to its reciprocal. So I'm going to write the denominator. 4a to the 3rd, -3, b to the 4th, -3ab. All I did was deal with this thing right now. I left everything that was inside the parentheses with the same signs. Now what I can do is if you want to move things, you can. So I could move this a to the -3 to the denominator. and get 4 and b to the 4th, negative 3, and then put a to the 3rd, a to the 1st, and b, still raised to the 2nd power. I can now combine these a's.
Sophie, baja la voz.
And then it's squared. Now I can also subtract the b's.
Sophie, please.
4b to the 3rd over negative 3a to the 4th, and it's still raised to the 2nd power. Now I have to square everything. So it becomes 4 squared is 16, b to the 6th, negative 3, it's in a parenthesis, so this becomes a positive 9, a to the 8th. I think it might be easier just to subtract the exponents instead of moving things around, but that's up to you. On this
Can
one,
you solve it by subtracting the exponents so I can see the other way?
okay, all right. So I'm still going to deal with the negative 2 first, so I'm flipping. So what I'm going to do is I'm going to subtract the exponents on the a's and subtract the exponents on the b's. So this will become 4 over negative 3. And then for the a's, what I'm doing is negative 3 minus 1. So I get a negative 4 here. So that tells me to write the a in the bottom with a positive though, positive 4. And then for the b's, I'm going to do 4 minus 1. So the b becomes b to the 3rd. It's a positive 3, so it's in the top. Then I just square everything now. So 16, b to the 6th, 9, a to the 8th.
Oh my God, my brain.
Okay, good. I'm going to do the next one that same way. I think it's easier to subtract. All right, this next one, again, it's a negative power, so I flip it to the reciprocal first. All right, so I'm going to work with the coefficients. 9 divided by negative 3 is negative 3. Then I'm going to work with my x's. 1 minus 1 is 0. Anything to the 0 power is 1, so those are gone. Now, no z's in the bottom, no y's in the bottom, so in this particular case, I'm just going to flip their spots. So this will go up, this will go down. So then I'll write y squared and a z. And then now, and it's got a negative down here, or I moved it to the top. Okay, so then z, and then it's cubed. Good? Now, if you wanted to leave and just simplify this and make this a 3 and make this a 1, you could also put the negative sign down here instead. Okay, so now I have to cube that. So negative 3 to the 3rd power is negative 27, and then y squared to the 3rd becomes y to the 6th, and then z cubed. All right, let's talk some fraction exponents now. Now, when I used to teach this to my Algebra 1 class, I would refer to the denominator, it's going to be the root, and the numerator of the fraction is going to be the exponent. So I would always tell them, think about a tree that's out in your yard. The roots are at the bottom underground, so that's why the denominator is the root, but the top is the exponent, and exponents are always in the top. So whenever you have anything raised to the 1/2 power, This is a square root. When you do a square root, they usually don't put the little 2 here. It's just assumed. When it's any other number, like a cube or a fourth root, they're going to take this root and they're going to write it right here, and that's called the index. So, and then this is technically raised with the exponent to the first, but if your numerator is a 1, you don't need to show that you're raising it to the first power. Over here, this is the root, so it goes here, and then that's the power. Let's try some examples. So we have 4 to the 1/2 power. This is the root. This is the exponent. So 4 square root, and then you would do the 1 exponent, but we really don't need to show it. And the square root of 4 is 2. This is the root, and this is the exponent. The cubed root of 27 is 3, and then I square it, and I get 9. Good? Okay, we have a negative fraction exponent. So remember, a negative exponent makes it go to the bottom. So it's now 81 to the 1/4 power, but it's under a 1. Remember, the denominator of the fraction is the root. And then I have to figure out what number times itself 4 times gives me 81. And that's going to be 3. 16, the root is 4. The exponent is 3. I know that the fourth root of 16 is 2. And then I raise that to the power, and I get 8. Next one. Negative exponent again. So put it underneath a 1. Make the exponent positive. And now we can write it with the radical sign. 1,000. You're going to find the cubed root of it. Once you do that, then you square it. The cubed root of 1,000 is 10. Then I have to do the exponent, and I get 1 over 100. This one, no parentheses, so this 1/2 power is only on the 100. So 100 is what's under the radical. The negative sign's outside, so I would find the square root of 100, and it's negative 10. Let me quick just do these last two. They'll be fast. We're finding the cubed root of negative 64 and then squaring it. Negative 4 squared, and it's 16. This one, it looks like 6, but it's different. Right now in this course, we're not learning imaginary numbers. So whenever you have the square root of a negative number, you're going to say that there's no solution, the empty set. Because I can't find the square root of a negative number yet, I haven't learned about imaginaries. All right, so now what I want you to do is do not turn these notes in yet. I'm going to change your due date until Monday, and then we'll finish up these notes on Monday. However, for the homework, you can do questions 1 through 12. I'm also going to move that due date and make it due on Tuesday. But my advice to you is go ahead and start this, because I'm going to continue on with the C notes on Monday. But you could at least get 1 through 12 done, and then I'm going to finish up the notes and everything on Monday. So nothing due for Monday. I'm going to adjust all the due dates. Same thing for the notes. Do not turn in the notes yet. I'm going to move the note due date till Monday. Everybody good? All right. Have a wonderful weekend, and I will see you guys on Monday.
Thank you.
Okay, you're
Thank you,
welcome.
Miss Corey.
Okay, you're welcome.
Thank you.
All right, bye. Okay, so again, homework, I'm gonna move the due date till Tuesday, and the notes, I'm gonna also move that due date. It's not due today, it'll be due Monday. I am gonna go ahead and continue with this video and finish up the last couple slides. So again, more practice of the same. So whenever you have something raised to a fraction exponent or a rational exponent, again, the denominator is the root. The numerator is the exponent. The cubed root of 27 is 3. Raised to the 4th power is 81. Same thing here. This is the root. This is the exponent. Square root of 64. And then you will cube the answer. This is 8. Cube it, 512. Over here, negative exponent, so let's immediately take care of that. Move the entire expression to the denominator. Keep that negative 32. Now we will find the 5th root of negative 32. And then raise that to the 4th power. Now, when your exponent is an odd number, we can find the root of an odd number index. But if it's an even number and this number is negative, we can't do it yet. So I'm going to find the 5th root, sorry, that's a 5. 5th root of negative 32 is negative 2. Then I'll raise that to the 4th power, and that gives me 1/16. Here is a fraction raised to a negative exponent. So the first thing I'm going to do is flip it to its reciprocal. That now makes that exponent positive. And now I can apply the roots. I can pull this apart and do the square root of 100 and get the 3rd power and then raise that to the 3rd. Same thing for the 121. Find the answer to the square root, then cube it. So this really becomes the square root of 100 is 10. Square root of 121 is 11. I get 1,000 over 1331. Some more examples. Back to what we learned yesterday on Thursday. When you have the same base and you're multiplying, we will add the exponents. So 4/3 plus 2/3 is 6 to the 6/3 power, which is 6 squared, which is 36. Same thing on this one, 125, same base. We're dividing this time. I will subtract 125 to the 2/3 power. Now I have to evaluate this. I'm going to find the cube root of 125 and then square it. Cubed root is 5, squared is 25. This one, again, I have the same base, it's r, negative 8/9 plus 17/9 gives me 9/9, which is 1 whole. So it's r to the 1st or just r. One more slide. So for here, we can do two things. I can move the negative exponents, or I could subtract, I could add the denominators. What I'm gonna do on this one is, since I already have a common denominator with these two, I'm gonna subtract these. So I'm gonna do z to the 3/4 minus 5/4 and get z to the negative 2/4, which is z to the negative half. And then what I have is I could move this one to the top. So then I would get z to the negative half times z squared. And then I would add my exponents here, and I would get z to the 3/2, or 1 1/2. Over here, I'm going to apply the power to the power. I'm going to multiply these. So this becomes z to the 1/5 times 15/1, y to the 2/3 times 15/1. And then remember, it also goes to the denominator. So then this would become, actually it's only on the numerator, sorry. So the denominator is just gonna stay x squared, because that 15's only on that parentheses. So then here, when I multiply this, I get x cubed. When I multiply this, I'm gonna simplify, and I get y to the 10th. And then I still have an x squared in the bottom. And now I can subtract these exponents. 3 minus 2 is 1, it's positive. X stays in the top, and the y to the 10th was also in the top. So final answer, x, y to the 10th. Last example, we're gonna multiply 3 times 1/4, and we get p to the 3/4. For the denominator, again, multiply p to the 10/4. And now I'm dividing, so I'm doing 3/4 minus 10/4. I get p to the negative 7/4. Negative exponent makes it go to the bottom of a fraction. And you're done. So that is it on the P2b notes. I will finish up this video on Monday, but for those of you who want to watch the whole thing, I completed the notes that you downloaded. That's it. Have a great weekend.